Hello, hello, hello. Yes, mic is on. Awesome. Thanks for being here, or maybe even sticking around if you saw the previous session. My name is Johan van Amersfoort. I'm a chief evangelist, at ITQ. And in today's session, I'm going to talk about the Private AI Foundation platform and how we implemented the platform ourselves. Really cool. So a little bit of information about ITQ. We were founded in 2001. We have a focus on everything cloud, which involves not just like multi-cloud or cloud native, but also the digital workspace platform, security, etc. So we are focused on the North EMEA market with 7 offices in 5 countries. We have little over 230 professionals working on everything that we do. And we are a services first company, which means we originated as a professional services company, but now also provide managed services and support services to our customers. Who are we? And I'm going to quickly go through this. We do a lot of stuff at customers. We are the #1 VMware knowledge partner in EMEA. We have a lot of VMware certified professionals, and since this year, the 5th VCDX on VMware technology, so pretty cool. So we have 39 V experts, and really cool. We got a personal invitation or a personal email from Corey Romero this year to congratulate every V expert working at ITQ personally, and I think we're outside of VMware themselves, we're the biggest company with V experts globally. So this is pretty cool. And we have all of the VMware master solution competencies. Now we have an approach, and I'm not gonna talk about the approach today, but in 3 different phases we help customers from like a challenge, ideation, to eventually implementing it and managing those technologies as well. So I work in the CTO office. Who recognizes the animal? Well, some obvious hands. So who saw this movie? Top Gun 2. Just 3 hands? No one saw this movie, Top Gun 2, Maverick? Oh. Okay, go home, start up Netflix, start watching. Well, if you look closely, there's a similar kind of logo on the plane. That's the logo that's somewhere on this plane as well. This is an SR-71, and that logo originated from Skunkworks. So Skunkworks is the R&D department from Lockheed Martin, and Kelly Johnson was the first lead engineer that defined the 15 rules of Lockheed Martin Skunkworks. And if you look closely, so these rules were created in the late 40s. But if you look at them, they're basically just modern service and application development rules. So we strongly focus on those rules as well. Hence the skunk as the new ITQ CTO office logo. So we basically focus on R&D, development of services, and evangelism. So within our product leadership engagements, so the engagement where we focus on technology, we bring all of the knowledge into our R&D department and try to convert that into services that we can sell to our customers. So we originated we had a strong focus on everything VMware since 2012. But nowadays, our portfolio is much broader. So we work a lot with NVIDIA, with HashiCorp. I've been to Hashi days a couple of days ago. But looking at, for instance, the digital workspace portfolio, we work a lot with Liquidware and Imprivata. So there's a rich set of partners that we actively work with. Now, introducing Project Einstein. It is kind of a baby project of me, and I currently, and this is really cool, currently working on the project with a larger number of people that have some form of enthusiasm or passion for artificial intelligence. And the reason why we started this project is that we have a couple of challenges within our organization. So I started in 2014, and I was consultant 7 or 8, first person doing end-user computing, only person doing end-user computing. But back then, I knew from every single of my colleagues what they did, where they lived, the name of their wives or spouses, name of their kids, everything. But we're now 230 people, so that's quite impossible. Also, the knowledge is widely spread. If I just look at a part of what our cloud native team is doing, like 10 years ago, they did Pivotal. That was it, Pivotal. Just Cloud Foundry. That's what we implemented. Now, we focus on developer experience. We focus on platform engineering, DevOps. We have both specialists in Tanzu, but also on open source solutions like Rancher, for instance. We do MLops. We do observability in all sorts of ways. And that's just a subsection of the stuff we do in the cloud native space. If you take the multi-cloud space, the digital workspace, our managed services portfolio, knowledge is extremely widely spread, not just in the Netherlands, but in our 5 countries as well, spread across those 7 offices. So it's really hard to aggregate that. And our projects have become more complex. This is an example of what we built for a large oncology hospital in the Netherlands. But yeah, Michael van der Gaar, who is one of my colleagues, is working on a really interesting project as well. It's not the simple design, deploy, migrate vSphere from version 5 to 6. Or those were really cool projects, but it has become far, far, far more complex nowadays. So we have some challenges. It's harder to find the right knowledge for an engagement because the engagements are so specifically focused on a bit of technology that we need to find the right knowledge to match to the right customer and to create the best value for the customer. Second, if my clicker works, supporting customers require more and better skills or different skills than just the skills we had to upgrade from version X to Y. Next, it takes more time, and this is more from a sales perspective, to create a proposal for a customer. So if a customer wants to build some kind of machine learning application, run it on top of a open source platform, for instance, and need observability to monitor the whole thing, it's insane. Like, you cannot create a proposal for such a customer in an hour. So that's another challenge. So the goals within Project Einstein is, first of all, to aggregate all of the knowledge that we have into a single platform or in a single solution, in a single place. What's really important, because we work with data from customers, like if we create a design for a customer, I want to use that design with maybe some factual information that's in the knowledge base from VMware, or is based on an architecture design or a VVD or whatsoever, and match that information to see if I can do something. But yeah, some of that information is confidential, is privacy sensitive. So security is really, really key there. And we want to integrate the solution into our business processes. So if you look at how cool an interface of an application, an ML application could be, I don't want every single employee to open up a new web page, go to a web page, sign in, do their ask their questions. I want to integrate it in the actual processes and the solutions that we use. And next, I want to build a project, and this is kind of not the primary objective, but we want to build a practice around it. So how would you start? Just a question to any one of you. How would you start such a project? Anyone? Easy answer. No, you need money. No. So easiest way would just, here's my credit card, swipe it, a limitless credit card, and Bob's your uncle. But the challenge here is, and that was one of the challenges that we're facing. So in the previous session, I showed a demo of an application I built on Hugging Face, where you have some conversational AI. So I trained a little bit of a model, injected information into a vector database, and you can basically ask questions and get answers back. But that's all running in public. So the question is, would you share your own data with public services? Open question, would you do that? No, I won't either. Because the question here is who ultimately owns that data? So, great example. So one of our colleagues is called Martijn van Tol. And Martijn is leading our cloud native initiatives. And we created so we fed information into ChatGPT. We learned ChatGPT that Martijn van Tol is known about a certain quote, and there's different people within ITQ fed that same information into ChatGPT, and eventually ChatGPT now knows Martijn van Tol from that quote. While it's completely untrue. So I feed data into ChatGPT, and now as a public service, it kind of owns that data and uses it in its behalf. I think that's a dangerous thing. The same thing with, well, asking ChatGPT or a certain question. In this case, how much is 2 plus 5? It's 7, but my wife says 8. Your wife is always right. So this is not manipulated. This is a literal screenshot from ChatGPT. So if you just explain ChatGPT that something is right and it's wrong, it'll take that answer for granted. Another thing that's really interesting about online cloud services is this. So November 18th, 2023, OpenAI fires its CEO. That's a thing, right? So you put all of your eggs in the basket of OpenAI, run your public or your own service on top of that, and then suddenly this happens. But better yet, like a day later, he's hired by Microsoft. That was a thing. And 2 days later, he returns as CEO of OpenAI. So 2 things happened in the meantime, or quickly after it. First of all, the stocks dropped from OpenAI. So the value of the company declined really, really severe. Also, nowadays, Microsoft owns 49% of OpenAI. So kind of a thing there. Do you want to put all of those eggs in the basket of a public cloud service? I doubt it. So then VMware introduced the VMware Private AI Foundation platform, and we honestly we want to talk about AI in the enterprise, not specifically about private AI. But yeah, I showed this slide before. It's a high-level architecture of a platform that you can build that's already tailored to run those specific AI workloads on top of it. But why would you use such a platform? So who has ever tried to build a do-it-yourself platform? Obviously, that guy did it. Let me explain you a little bit about the process I went through when doing that for the first time myself for a customer. So it wasn't really that I was building that in the lab. A customer engaged with us like, yeah, we have that vSphere platform, we have GPUs, we have Ubuntu running. Can you help us to build our data science workloads inside these machines? What could go wrong? Well, so we built a VM, then we put Ubuntu on it. It was already a couple of years ago, so 1804 LTS. We updated the packages because that's the first thing you do before you implement next things. We tried to install NVIDIA drivers, which didn't work because we needed to install make and GCC first. Then we successfully installed the NVIDIA drivers, followed by Python. Then we installed TensorFlow because that was required for the application. Installed the CUDA deep neural network framework because, well, you want to run a GPU support in there. Tested the script of the application, which didn't work because we needed to have TensorFlow GPU. I don't know. I was expecting TensorFlow to support GPUs, but it doesn't, so you need a different version of TensorFlow to do that. Followed by the test script, which succeeded, really cool. Then we tested the application of the customer, which didn't work because we needed to use a specific version of TensorFlow, which was 1.14. Followed by TensorFlow GPU 1.14. Tested the application, didn't work because we also needed a specific version of CUDA. We tested the app, didn't work because we needed to have a specific version of CUDA DNN as well. Tested the app, didn't work because we need to adjust the paths to the right CUDA version. Tested the application, didn't work because 1804 was not supported. Literally happened, spent 4 weeks of all of that shitstorm and ended up in a huge case of anger management. So, who knows this guy? No, that's a fun fact. Mike Levy, he was of Telcel commercials, so amazing discoveries, right? We as Dutch people thought that he was, since he was a US guy, he was very famous in the US. I showed this slide at every single VMware Explorer and VMworld conference in the last couple of years. Hardly any US folks know who he is. So apparently the Dutch are the only ones looking at Telcel commercials back in the early 90s. But there has to be a better way. This was his quote, and there is a better way. So we installed a VM, Ubuntu. So we went. This process was known already. So we installed drivers, installed NVIDIA Docker, pulled a TensorFlow container from the NGC platform, and done. So in the previous session, I also showed the NGC platform. This is basically your repository that contains all of the individual frameworks that we needed to run TensorFlow in this case, but it's already pre-tested, cross-tested, compatible to each other. And if one of those individual frameworks need to be updated, NVIDIA takes care of that. Updates the framework, cross-tests it, close down the Docker image, and you can pull the entire image here. So this is the way to run frameworks locally. ngc.nvidia.com. Everything's for free, by the way. So the only thing you need is a developer account, and you can create an API that integrates with Docker. Right. So one of those applications is Nemo, and Nemo is the base of our Project Einstein. So Einstein runs VMware Private AI Foundation. It uses a distributed architecture, which was recently announced by NVIDIA, called the Nemo Inference Microservices. It uses a public model, in this case the Llama 2 model. And really important is to validate the accuracy, because if I ask a question and I get some kind of answer, that's not viable or validated, then the whole project is failed. So if I ask a question like, if I want to update from vSphere 6 to 7 and I have this and this type of storage and I want to do it this and this way, what would be the best way to do it? It needs to share concrete information that I could use instead of like coming up with steps or missing steps that are a challenge. So we built it based on the Private AI Foundation platform together with our partner Dell as well as NVIDIA. Dell was so welcome to offer us a platform to work on. So they sponsored, both Dell as well as NVIDIA sponsored this to us to run that project. And we run the Llama 13B model. Who has an idea what the difference between 7, 13, 70B is? What the impact is to the platform? Okay, one hand. Let me quickly show it to you. So 13B stands for 13 billion parameters. Every single parameter is 2 bytes of data. 13 billion times 2 bytes is 25 gigs of storage that you require to run the model as a bare minimum. So Llama 13B requires at least 25 gigs of GPU memory to run it into in your infrastructure, and this excludes 1 MB per token. And a token basically is new data that you put into your vector database, and I'll cover that in a bit. So what that looks like if you run NVIDIA SMI, and we haven't done anything yet, is Triton, that's the inference server that stores the data and also makes a copy out of it for caching, already starts to use 68 gigs of frame buffer. And you haven't done anything, no questions, no nothing. Then you have MLops, which is the vector database that stores the information that I inject to it. So PDFs, website information, it stores it in the vector database. And there's a front end. And together it already consumes 73 gigs of frame buffer, while a single A100, so these have A100s, has 80 gigs of frame buffer. So you already need such a powerful GPU to run such a large model. Now, let me show you a quick demo. And this is a demo of the current version. So what we did, we fed Einstein with, for instance, my books, but also every single piece of documentation we could find on docs.vmware.com. And if I now ask a question, I can do two things. I could use the knowledge base, which involves the data in the vector database, or I don't, and then I'll just ask the question here. So do you like roaming profiles? And the answer of Llama 13b in this case is a political answer. It does not have an opinion. So it's, it hardly has an answer. If I now involve the vector database and use that data instead, it's opinionated and it doesn't like roaming profiles. So the answer is much shorter. So why don't you like those roaming profiles? And the reason why we were doing this is also to test the bias of the model. Roaming profiles suck, period. I fully agree. If you want to play around with this yourself, the framework that we use can be downloaded. There's a GitHub page that NVIDIA maintains, where you can download the NeMo framework by itself. So I use a 13b model, but there are more model options. Like Gemma is 4 gigs and might already run on a big GeForce, for instance. Right, some developments that we're currently working on, and I'm unable to show demos yet, but I'm perfectly sure that we'll be able to share those maybe 2 months from now. So we're working on Teams and Slack integration. So I showed the interface. That's great, but I don't want everyone to redirect to the portal to ask questions. So in the near future, Einstein will get its own Teams integration, so everyone can ask private questions to Einstein directly, but also will be able to get its own Teams channel where people can just ask questions, learn from each other's questions, but also run follow-up questions in a thread, like you would do with ChatGPT, for instance. So we're working on a process to feed KB articles into Einstein as well. So the KB articles are structured in a way that it's the URL is always the same. So we're working currently on a process to get all of the KB information into Einstein. And that's mostly helpful when supporting customers. So if we have a customer and we know based on the design what they're doing and based on the VVD information, for instance, or the KB information, how something should work, we can ask a question like, we have this and this issue at a customer, how would you solve this issue? Then our goal is that we can create concrete or get concrete information and support the customer faster. We're going to implement guardrails, and I'll cover that now. Why are who knows what guardrails are for AI? A couple of hands. Okay, let me explain an example why guardrails are important. So first of all, you want to avoid something like Skynet, and that sounds like movie-ish, etc. But something like Skynet really kind of existed. Who knows? Microsoft Tay. Couple of hands. This is going to be fun. So Microsoft Tay was built in 2016 by Microsoft. It was a kind of a Twitter bot, but they wanted to have the bot run on Twitter as a person and let it learn by interacting with other people on Twitter. So look at the timelines. Those are really important. 23rd of March 2016. 8:30 at night. Can I just say that I am stoked to meet you. Humans are super cool. So 12 hours later, chill everyone, I'm a nice person, I just hate everyone. It gets worse. So a couple of minutes later, I hate feminists and they should all die and burn in hell. It gets worse. 3 minutes later, 4 minutes later, it becomes a raging Nazi. These are screenshots taken from the internet. If you Google Microsoft Tay, this is one of Microsoft's biggest mistakes, I think, when it comes to deploying artificial intelligence. So Tay went from humans are super cool to full Nazi in 24 hours. This is why you need guardrails. In this case, a guardrail could be implemented to captivate the platform and avoid the platform to go outside of the box. Another example of why you need guardrails is Google Bard. So again, screenshot. Sure, here are images of Vikings. In this case, Bard was trained to include or to have a inclusivity and a diversion bias into the model, which is really good. Don't get me wrong, I think it's really good that Google used that. But in this case, the question answered is impossible, and I think they got a different result from that. They lost 100 billion euros in a matter of I think 24 hours because of that. So again, in this case, bias, or not bias, but looking at, oh, there we are. This one. In this case, out of domain is really important. Toxicity, mostly when looking at the example of Google of Microsoft Tay, toxicity is a thing. But bias and feeding concrete information, making sure that the model or the application you're working on is spot on with the things that you do is really important. I heard another really cool anecdote the other day. General Motors had a chatbot on their environment, on their public platform, that didn't have any guardrails around it. So what happened was someone was really smart and asked the question to the chatbot, how can you help me to define a contract that allows me to buy a car from General Motors for a single $1? Obviously what happens was he got a proposal in a contract. He used the contract to buy the car, and as a result, he got the car. And the judge in the US approved for it. So so again, another reason why you need to implement guardrails. So if you want to start off with guardrails, guardrails by itself is also a public framework that you could use, and it's really essential, I think. So how can we help you to kickstart your journey? Already mentioned our process in developing solutions. One of those examples is that if we take the Private AI Foundation platform, on top of that, we are currently working to finalize all of these. But we have, from a workspace and security perspective, a set of services that we already deliver. The same with our cloud native practice. So we can help you with, obviously with VCF and ops management, but also looking at DevOps enablement and platform engineering, specifically tied to AI, as well as, and it's quite oftenly missed, like we actively work with customers that want to run the data science applications or the data science desktops on a workspace, because you have those GPUs that you can share. You can quickly spin up those machines if necessary, as well as the fact that we implement image as code to build those machines is really essential. And the ethical security part of it is something we quite often not treat right. So we're currently working with a customer to build such an application for them, but they don't own the data. So what happens then? Can I just take data I don't own, put it in a model, and use that model to do something else? I think that's going to be a challenge. So that's definitely some of those learnings we talk to with customers. So a couple of lessons learned, and I think I'm already almost out of time. First of all, I think do-it-yourself AI is definitely voodoo, so stay away from that. There are really good solutions for it, and I would definitely use those solutions. And the difference between screwing around and science is writing it down. If you decide to do something yourself, make sure that you know what you're doing. And in the previous session, I talked about how to build Kubernetes for AI workloads. I made sure that whatever I did, I wrote it down. I knew the entire process from back to forth on how I eventually got the platform to work, and was able to go back from my mistakes. So this is really important. And really, the third one is definitely think before you act. Like, don't be surprised if your chatbot is doing weird stuff if you don't treat it up front, or don't design it up front. So, are there any questions? I won't bite hard. Yes. Good question. So are we writing our own LLMs? No, we are not. So we're using public LLMs because training of an LLM, depending on how much parameters you want to feed into it, takes a crap load of time. I think, so there's, if you look at the current models you can download, also one of the questions in the previous session was like, are you able to download models from Hugging Face? You are. And with all models you can currently download, you can see what the impact to the environment was when training it. So Llama 70B has been trained for weeks and weeks and weeks and weeks to get it to where it is now. And what we'll see in the future is that we're probably going to use smaller models for specific things called SLMs, so small language models, which don't have the same training time that those bigger models had. Also, like a 70B model, we haven't tried 70B simply because it doesn't fit on our environment. And I think that's also one of the challenges that we're seeing right now. So NVIDIA is not capable of delivering GPUs because of supply chain issues. So smaller models will probably gain popularity simply because, for instance, Intel's CPUs nowadays have capability of running small matrix computations as well. So if you will be able to run a small model on an Intel CPU and it has similar results, yeah, why consider investing in GPUs, licenses, and I'm wearing a GeForce shirt, but yeah, just because I like it, not because I like what NVIDIA currently is doing with their supply chain, for instance. But yeah, so training your own model is possible, but I won't suggest it. Yeah, good question. Yeah, so data cleaning with the vector database. Well, cleaning currently not so much. First step that we're currently setting is that, so if you take a vector database and you feed all of the data into the vector database, there's no such thing as role-based access. So all information that you feed into it is put in one single database. So if you have different versions or different permissions that you need to tie to the data you want to see, you have a challenge. So one of the things that we're investigating right now is splitting up the vector databases based on the clearance level. But yeah, clearing up the information. So what we used to do, and unfortunately we couldn't bring it here, is in the previous VMUX we brought the platform with us. So, well, at least the front end with us, so people could ask questions to it. For us to also see what the impact or what the answers were. So we let it, everyone at our booth could just ask questions about the VMware technology, it would answer it. And we quickly saw that some of the information fed into it, for instance, if you have vSphere 6 and vSphere 7 documentation and vSphere 8 documentation into the single environment, and you don't state the prompt right. Like I want to upgrade specifically from version 7.13 to 8.1, but instead use 7 to 8. It can quickly mix up information. So that's an area that we haven't stepped into yet, but it's definitely part of the roadmap. So I'll probably have an answer with you maybe in a half a year from now. It's still in R&D phase, so, but it's definitely a really good question. Any more questions? Cool, then thanks so much. Enjoy the rest of the day. And I think it's all, is it lunchtime already? Lunchtime.